Bismillah ar-Rahman ar-Rahim. Inshallah, we'll continue. Section 3.1. What they want here, just they want the derivative. Derivative, which is, you can do it from here. This is what? 1 minus x to the power minus 1. If you know the formula, it will be minus 1 minus x to the power minus 2. Don't forget, you need the derivative of this, and the coefficient of x is not 1. That will be, you need another minus times minus 1. So that will be 1 over 1 minus x all square. Or you can do it through the limit. Is nothing. That will be what? Limit. It goes to 0. 1 over x plus h. 1 minus x minus h. Minus 1 over 1 minus x over h. So that will be limit. It goes to 0. 1 minus x minus 1 plus x plus h over 1 minus x. 1 minus x minus h times h. Cancelled. Also, it's cancelled. Take the limit, this goes to 0. You have 1 minus x squared, which is this. Yeah, I want to be sure about one thing. Okay, what the following statement is true. If this limit exists, that means what? F prime at A exists. So F is differential. This is true. If the limit exists, does that mean the function is differentiable? No, it's not related. The function is differentiable if this limit exists, not the limit of the function. So this is wrong. If the limit exists, does that mean if it's continuous? No. I need also f of a. So this is wrong. If it's differentiable, this is what? If it's continuous, and we know that differentiability means continuity. If the function is differentiable, or let me say it, first you need to check continuity. If it is, then you need to check differentiability. So you will not reach differentiability unless you pass the continuity test. So if it's differentiable, for sure it passes the continuity test, so it's continuous. So 1 and 4 are the correct ones. Which one of the following statements is true? Let me do the wrong one. If it's not differentiable at x equals 0. No, what we care about, this is where it had corner at 6. This is the graph of this function. So this is not at 0, at 6. X squared equal cosine x has no roots. We cannot conclude this. This is g of x is x squared minus cosine x. Where g at minus pi is what? Is pi square minus cosine pi plus 1, which is positive. G at pi, it will be pi square also plus 1, which is positive. So both positive. That does not mean we don't have a root. The immediate value is saying what? If one is positive, the other one is negative, then there is a root. It does not say anything if both are positive or both are negative. And actually, if you look at these things, this is what? You know the graph of x squared, and you know the graph of cosine. So for sure there is a root. Actually, there are many roots. So this is wrong. If it is continuous, then it's differentiable? No, the other way is correct. So this is wrong. If absolute value of x is continuous, then if it's continuous, no. This is wrong. If absolute value of f is continuous, it does not mean that f is continuous. You can do something like this. You know how to find f if you have a function like this. No, you want function, not continuous. Yeah, I know, I can't have a function. This is make it at -2. I'll make it start at 2. Okay. This is not continuous. Absolute value of this, what will happen? All of this will go like this. Absolute value means what? The negative part will make it positive. So it becomes what? Continuous. So the absolute value of f is continuous does not mean f is continuous. So this is wrong. This one is correct. Why? You deal with this f of x, e to the power x minus 3 plus 2x. F of 0, give me what? E to the power 0, 1 minus 3, which is negative. F of 1, give me e minus 3 plus 2, which is e minus 1, which is positive. So I have negative and positive. So for sure, intermediate value theorem, and this function continuous, actually, this interval. So intermediate value theorem shows there is a root. So this is the only one. Now we need to do this f prime from left, f prime from right. This is just a definition. Limit is goes to 5 from left. I'll do this, then I'll do this. F of 5 plus h minus f of 5 over h. How to do this? I say 5 plus h, where no, h goes to 0 from left. 5 plus h, where is h goes to 0 from left. So this is less than 5. Where I am here. So just so substitute the function, which is 2, 5 plus h minus 9. F of 5, just substitute there. F of 5 is what? 1 over 10 minus 9, which is 1 over h. So that will be what? Limit is goes to 5 from left. Do the calculation. 10 plus 2h minus 10 over h, that is 2. What about this one? This will be limit as this goes to 0 from right. For this one, f of 5 plus h minus f of 5 over h. But now this one, as it goes to 0 from right, this will be greater than 5. So I am here. So I'll use this function in this case, which is 1 over 2 times 5 plus h minus 9. F of 5, I did it before, it was what? 1 over h. So let us do the calculation. That will be what? This is what? 10 plus 2h minus 9. So this is 2h plus 1. So it will be 1 minus 1 minus 2h over h. قلنا هذا كم؟ 1 plus 2h. So this is cancelled. Also the h cancelled. H goes to 0. I'm getting to minus 2. So this is 2 minus 2, which is 0. So this is the answer. You want f prime from left? The same idea. To build the limit, h goes to 0 from left. F of 3 plus h minus f of 3 over h. 3 plus h from left. I am where? I am here. So this will be limit. H goes to 0 from left. Substitute 3 plus h here. It will be 4 minus 3 plus h. F of 3, I am here. It will be 1 over h. That will be limit. H goes to 0 from left. 4 minus 3. 1 minus h minus 1 over h. Cancel. That will be minus 1. So the answer is minus 1. Now, let me move to the next one. This is the next one. The same thing. Check f prime from left for this function at 1. So that will be limit. H goes to 0 from left. F of 1 plus h minus f of 1 over h. That will be limit. H goes to 0 from left. F of 1 plus h, just substitute. I have 1 plus h. 1 plus h minus 1. F of 1 will be 0 over h. So that will be limit. H goes to 0 from left. 1 plus h. This is what? Absolute value of h over h. Now 0 from left, so this is negative. So get rid of the absolute value. 1 plus h minus h over h, cancel, cancel. Substitute at 1, at 0, I mean, you get minus 1, which is this one. F prime from left, that will be limit. H goes to 0 from left. F of 0 plus h minus f of 0 over h. So that will be limit. H goes to 0 from left, greatest integer. H, apply 0 plus h, which is h. Apply it here. That will be h, greatest integer of h. F of 0 is 0 over h. So this is cancelled. So we have limit. H goes to 0 from left of the greatest integer of h, which is minus 1. This is the answer. Add 2, that will be limit. H goes to 0 from right. F of 2 plus h minus f of 2 over h. Do the calculation. This is 0 plus, so 2 plus, I am here. I use this one. So I have 4 over 6 minus 2 minus h. F of 2, I am here. 4 minus 3 minus 1 all over h. واحد المقامات. We get what? 4. This is what? 4 minus h. So it's 4 minus 4 plus h over h before minus h, right? Yeah, this is 4 minus h. Yeah. So this is cancelled, cancelled. H with h, I'm getting 1 over 4, which is this one. You want what? F prime from left. That will be what? Limit h goes to 0 from left. F of 2 plus h minus f of 2 over h. That will be limit. H goes to 0 from left. 2 plus h from left. I am here. So I'll put this number 2 plus h to the power 4. Let's think. Plus 1. F of 2. F at 2 is what? F at 2. You put 2 there. 2 is to the power 6. 2 to the power 4, 16 plus 1, 17 over h. So it will be limit. H goes to 0 from left. 2 plus h to the power 4 minus 16 over h. Now I try to factor it. This will be what? Like difference of 2 squares, so it will be 2 plus h square. Consider it first square, huh? So consider 2 plus h square minus 4 square. Okay, so this is minus 4. 2 plus h square plus 4 over h. This one I can factor it, or I can simplify it. Let's check it. This is what? 4 plus 4h plus h square minus 4. Which is what? This one will be limit. H goes to 0. Here I can take h also common factor. It will be 4 plus h. H, 4 plus h, the rest. Plus, because I need this h to cancel this h. Now I can substitute. So that will be 4 times, this is 0, 4 plus 4 times 8, which is 32, which is this answer. Just a matter of calculation. Yeah, this kind of problems. Suppose that if it's differentiable, satisfy this relation. This relation is always true for any x and y. And the limit is equal to minus 2. This limit is equal to minus 2. This limit means what? Let me check. Yeah, limit x goes to 0. F of x minus 1 over x is equal to minus 2. This limit means what? Can I find f at 1? It does not give me f at 1. Let me forget. Okay, this is just information. Let me see what will happen. I will do f prime at x with the formula. So I try limit h goes to 0, f of x plus h minus f of x over h. This is the formula. So I'll use this relation. I'll try to use this relation. Using this, what will be f of x plus h? I'll consider x and y equal h. So that will be limit h goes to 0, f of x plus f of h, okay, plus 2xh minus 1. What I did, I only take x and I put h and put yh, and I write the formula minus f of x over h. I hope this is clear. So now cancel f of x with f of x. What is the remaining? That will be limit h goes to 0. And notice something here. F of h minus 1 over h. This is this one. It is x or h. These are just dummy variables. Plus 2xh over h. This is cancelled. This is x is not related to h, so I can take it out. So this is this limit. Now I distribute the limit. This is no h, so this is 2x. This one is what? This one is similar to this one. Is this one exactly? So this is minus 2 plus 2x, which is this one. I hope it's clear. Let me defined. Find f prime at 3. He gave you a relation, a and b. Who cares? And you want f prime at 3. Okay, f prime at 3 equal limit h goes to 0, f of 3 plus h minus f of 3 over h. I plug it here. Look, if I put this 3 and this is h, so this is what? F of 3 plus h minus f of 3, which is my expression here, is equal to 4 times 3 times h plus 2 h squared. So this will be equal limit h goes to 0, 12h plus 2h squared over h. Done. I just put the formula. Take h common factor, 12 plus 2h over h, cancelled. So the limit is 12, which is this. These are some ways to force you to use the formula. Same idea. I want f prime at 0, limit h goes to 0, f of 0 plus h minus f of 0 over h. Put this 0, this is h, do the formula, and see what will happen. It will be f of 0 plus f of h minus f of 0, f of h. This is just the expression, minus f of 0, all over h. This is f of 0, f of 0 cancel. But he gave me something. He told me f of 0 is equal to 1. So that means what I have, limit h goes to 0, f of h minus f of h over h. That will be 0 over h, which is 0. So the limit is 0. Vertical tangent line. Yeah, I think this is maybe more towards 3.4. It's very difficult to find it. But if you know the formulas, this is 1 over 5, 1 minus 2x to the power minus 4 over 5 times minus 2. So it means what? Minus 2 over 5, 1 minus 2x to the power 4 over 5. As you agreed, when you have vertical tangent, x equal a, let me write the conditions. x equal a is a vertical tangent. Two conditions. F, vertical tangent of f, if it's continuous at x equal a, this is number one. And the second one, second condition, limit as it goes to a of the derivative is equal to infinity. I took the absolute value to avoid writing plus and minus. Maybe our book is doing it, goes to infinity, goes to minus infinity, it's the same idea. If you notice here, you can find the derivative. The problem is not easy to find it. So I think this question, we cancel it at that time. We say if it's continuous, yes. If it's defined, so if it's continuous at x equal half. Actually, it's continuous everywhere. We have no restriction. But it's continuous at x equal half. You notice here, limit x goes to half. For this function, it will be what? Non-zero over 0. And this is will go to 0 with the absolute value. It will go to plus infinity. So a vertical tangent at x equal half. This is the most famous function, which is easier to do, cubic root of x, which you can do it through the definition. There's x to the power 1 over 3. So if prime is 1 over 3, x to the power minus 2 over 3, which is 1 over 3, x to the power 2 over 3. So if it's continuous at x equals 0, and the limit of the absolute value of x, as this goes to 0, this will be plus infinity. So we have x equals 0 is a vertical tangent. Vertical tangent. What is the point? 0. He wants the point here. So 0, just substitute there. So it's 0 and 0, which is this one. Here is asking when the function is not differentiable. So we have some problems when the function is not differentiable. So we need to check it one by one. First, check inside each part of this. This is linear function, nothing to worry about. This one, I have a problem at x equals 3, where the function is not defined, so it's not continuous. And 3, is it in this interval? Yes, so this is point number 1, since it belongs to the interval 2 and 5. Okay. This one, the absolute value, I know there is a corner, so I have a problem with x equal minus 1. Is it in this interval? Yes, so this is point number 2. Okay. Well, where are the other points? You need to check this junction point, which is 2 and 5. Check the continuity first. At x equal 2, what will be the limit as goes to 2? From left, I want to check the function continuous or not. It will be 3. Limit as goes to 2 from right. It will be what? Minus 1. Minus 1 over minus 1, 1. So this is point number 3, since f is not continuous. At x equal 2. Here is not continuous, برضو. Here there's continuity, but we have a corner or sharp term. Now for 5, x equal 5. I want to check x equal 5. What will happen? Limit as it goes to 5 from right. It will be what? Minus 1 over 2. Minus 1. From right, no, it's not minus 1. From right, I'm here. So it will be 1 over 4x plus 5, which I just substitute. You have what? 5 over 4 plus 5. I don't care about the number. Limit x goes to 5 from left. I will be here. So it will be minus 1 over x minus 3, which is minus 1 over 2. For sure, they are not equal to each other. So this is for point number 4, where f is not continuous. By the way, if it is continuous, it doesn't mean it's differentiable. Huh? If it is continuous, doesn't mean it's differentiable. You need to check something else. So we have 4 points. 3 no continuity and 1 corner. From the given graph, there is no given graph, so we just leave it. In which of the following intervals the function is differentiable? I know when this function is differentiable, this is absolute value of x minus 2. Is it not differentiable? If it's not differentiable, at x equal 2 only. They want the interval in which, so if the interval contains 2, I have a problem, I cancel it. This one contain 2, yes, out. Contain 2, yes, out. Contain 2, yes, out. Contain 2, yes, out. This one contain 2, no. So this is the correct. Oh, this question is complicated one. It's not that difficult, but it's, well, it's a little bit difficult, yes. Definition, limit, it goes to 0. When we say the function f prime exists, means the limit exists. F of 0 plus h minus f of 0 over h. It will be limit. It goes to 0. I'll put the numbers. H 2p tan inverse 1 over h. F of 0, he says it's 0 over h. So that will be limit. It goes to 0. H 2p minus 1 tan inverse 1 over h. So you want to check this limit. When it exists, when it does not exist. Okay, take 3 cases. Case 1, 2b minus 1 equals 0. And case 2, a negative, positive. If it is 0, what will be f prime at 0? The limit. It will be limit. It goes to 0. H to the power 0, which is 1, tan inverse 1 over h. I know this limit does not exist. Why? Because limit as it goes to 0 from right, tan inverse 1 over h, that will go to plus infinity. So I'm going to pi over 2. Limit as it goes to 0 from left, tan inverse 1 over h. This will go to minus infinity, so I'm getting to minus pi over 2. Because of that, this limit does not exist. Okay. Number 2, 2b minus 1 negative. What will happen? I have limit. I will try to just sketch the argument, as they say. This one is something bounded. And this one, as it goes to 2b minus 1, means this power is this power is negative. So it means the value will be in the denominator. This power is negative, so the value will be in the denominator. When you have bounded over, I mean, as it goes to 0, so this will be 0 in the denominator. So bounded over 0, this will go either to plus or minus infinity. So because of that, this is rejected. The case 3, 2b minus 1 positive. I have the limit. It goes to 0 of this function. H to the power 2b minus 1 tan inverse 1 over h. This is positive, so the power is positive. And this is bounded. This goes to 0. 0 to something positive, it will make it 0. But here, 0, something negative, it will make it go to plus infinity. 0 to the power of negative. So it will be 0 in the denominator. This is what I meant. Yeah. This one, you can do it using squeeze theorem. I have tan inverse of 1 over h between minus pi over 2 and pi over 2. I can multiply by this. Times pi over 2. And this is minus pi over 2, h to the power 2b minus 1. Right. Now, as h goes to 0, this one will go to 0 since the power is positive. So this is 0. This is 0. So for sure, this goes to 0 by sandwich theorem. So in this, the only case where I have a limit, or the limit exists. This limit exists. This case, the limit does not exist because the right not equal to left. This case, as I said, it will be something over 0, which is because the 0 will be the denominator because this is a negative power. So this is the only case, and this is my answer. So I need 2p minus 1 positive, p greater than half, which is very complicated question. This is the only time we saw it, and we did not see it. We did not see anything like that for a long time. I want to do this. So do f prime plus, that will be limit. It goes to 0 from right of this expression. Actually, let me do it. Yeah, let me do it for okay. That will be f of 1 plus h minus f of 1 over h. That will be limit. H goes to 0 from right. F of 1 plus h. That is what? 1 plus h. 1 plus h minus 1. That's absolute value of h. F of 1 is 0 over h. H positive, so this is positive. So this will be limit. H goes to 0 from right. 1 plus h. H over h cancelled. That will be 1. F prime from left. That will be limit. It goes to 0 from left for the same expression, which is the same. I just substitute 1 plus h, absolute value of h over h. But now this h is negative. So there is a minus sign. So this is the limit. This goes to 0 from left. 1 plus h minus h over h. It is cancelled. Substitute, I'm getting minus 1. So this is 1, this is minus 1, so it will be 1 plus 1, which is 2. So this is the answer. Yeah, there are some questions like this one. Differentiable, a function is differentiable everywhere. You need to find a plus b. One good way to find f prime using for the piecewise function, you can do it this way. F prime will be, find derivative of this, find derivative of this. That will be 6x, and that will be b. But be careful. This is true, but at 0, you need to check it. But since in this question he said it's differentiable everywhere, it means at 0 also should be correct. Either you put it there or there, there is no problem. So that means what? And by the way, if the original function is continuous or continuous everywhere, that will represent f prime from left at 0, which is 0, and that will represent f prime from right at 0. At this point, I mean. So for f prime, actually it will be this f prime at left, and this is f prime at left, and this is f prime at right. Okay, now let me go back to this one. Now this one, this at 0, this one should equal to this one. So 6 at 0 should be equal to b, so that means b equal 0. Okay, but this is one condition. How to find a? I noticed something. It said differentiable everywhere. It means it's continuous everywhere. As we said, it will not reach differentiability unless it passes the continuity condition. Continuous everywhere at 0, continuous at 0. That means what? I have a equal what? Minus c. Just substitute here. Substitute here, a equal minus c. So this is a, this is c. What will be a plus b? It will be 0 minus c, which is minus c. So this is the answer. And I think I'll stop here. Okay, thank you.